Guess what? Solving a polynomial to find all the real zeros of that polynomial does not have to be complicated. I know it can be tough when you're first learning it. I think everybody struggles with new things, especially in math. But there really is a very easy process that you can go through to solve for the zeros of any polynomial. And I'm going to be showing you that process in this video. I am going to be doing a specific type of example in this problem and solving it a very specific way that is very easy for examples that fall into this category. But it is a very common category. So seeing this process should really help you out and make these types of problems a lot easier for you going forward. So without further ado, let's go ahead and jump right into it and I'll show you what I'm talking about. Find all the real zeros of the polynomial function. This time the function that we have is f of x equals x squared plus 10x minus 20 or plus 25. I'm sorry. So let's go ahead and talk about another way that we can find the zeros of this function besides factoring. Now, still the thing that you want to keep in mind, if you're ever trying to find the real zeros of a polynomial, that means that you want to take the whole equation and set it equal to 0. So it's the same approach whether you're going to be factoring or not. That's all finding the zeros of a function in general means, is that you take your function, set it to 0, solve for x. That's really the approach. You know, how you actually solve for x is kind of where the different variations of ways that you can solve the problem come into play. Or also, you know, if you're dealing with a quadratic specifically, like we are in this case, the approach may be a little bit different than trying to find, you know, a cubic or any other type of polynomial function equaling 0 like this. But when you have a quadratic specifically, which is anything that is in the form ax squared plus bx plus c, in other words, you have an x squared term, or whatever your variable is, your variable squared term, and then an x term, and then a constant term. Whenever you have these three terms, that makes it a quadratic. You can use the quadratic equation. So the quadratic equation just tells us that if you have a quadratic, which we do here, and it's equal to 0, and you're trying to figure out what x values solve that equation, you can use the quadratic equation, which just says that those x values are going to be x equals, and there's a little song that kind of goes along with this. That's how I always remember it. Me personally, you can kind of sing this to the tune of Pop Goes the Weasel. So this is how I always remembered it. The opposite of lowercase b plus or minus the square root of b squared minus 4ac all over 2a. And I'll go through that. I know that was kind of fast. We'll come back to that, but that's kind of the song that I like to use to remember it. So it just goes the opposite of lowercase b, so negative b, plus or minus the square root of b squared minus 4ac all over 2a. So that is kind of the song. If it kind of helps you to have that song, that always has made this formula a lot easier for me to memorize. Thank you, Miss Kevin, my 7th grade teacher, taught me that one. But yeah, so basically we have x equaling, now where the b, the a, and the c come from are just the coefficients of your x squared, your x term, and your constant term. So exactly like what I have here. Your a is just the coefficient of your x squared term. So in this case, we don't have a coefficient. That basically implies that your a is 1. Our b is the number that goes with our x term. And then our c is the constant number that's all by itself. So if these three terms were in a different order, like let's say we had 25 plus x squared plus 10x, you want to be careful here because you still would treat 1 as your a, 10 as your b, and 25 as your c. So it's not important what order they are in the equation. What's important is what coefficient goes with the x squared, the x, and then the constant number all by itself. So that's really all it comes down to. So let's go ahead and just kind of plug these things in here. So 10 is b, so we're going to have negative 10 plus or minus the square root of b squared, so 10 squared, minus 4 times a, which is 1, times c, which is 25. And then make sure this is all within the square root here. So you need to make sure that all these terms right here are all inside the square root. And then that's all going to be over 2a. So 2 times your coefficient 1, 2 times 1. Okay. And then you can pretty much just simplify this. So From there, you're just going to go x equals -10. You pretty much want to start with simplifying what's inside the square root here. So you're going to get 10 squared is 100. So the square root of 100 minus 4 times 1 times 25 is minus 100 all over 2. 2 times 1 is just 2. So we'll simplify that to a 2 right there. Okay. Now 100 minus 100 is 0. So inside the square root, we're going to have 0. So that just tells us that we have -10 plus or minus the square root of 0. Well, the square root of 0 is just 0. So that's just going to be -10 plus or minus 0 all over 2. Well, plus 0 or minus 0 still just leaves you with -10. So you're going to have just -10 on the numerator over 2, which is -5. So this is a unique kind of situation where whenever you get 0 inside the square root like this, that basically tells you that your quadratic only has one root, because you're going to end up with something plus 0, something minus 0, which just gives you the same number. That you're not like adding a number or subtracting a number, you just have one result. So in this case, x equals -5 is going to be our only real root of this equation, because it's the only number that we got out of this quadratic equation. Now, really what that tells you is that this quadratic that we had here, this equation, the vertex is on the x-axis. If the vertex of a quadratic is on the x-axis, that tells you that that one vertex is the only point that hits the x-axis. So there's not going to be two roots when that happens. There's only going to be the one, which is the vertex. Well, it's not feeling so tough now, right? Hopefully a little bit easier at this point. Trust me though, you don't want to stop here, because although the method we talked about in this video is easy and applicable for a lot of different polynomials, there's other methods and other types of examples you need to be familiar with. Go click that video right there. I'll show you another example with a little bit more universally applicable method that you can apply. By the end of that, not only will this feel easy, but you'll be feeling like a pro.